Hey everyone, welcome back to the deep dive. You know, we always go for those big, juicy ideas here. And today, we're diving into something that's going to really stretch your understanding of, well, pretty much everything.
Oh, yeah. It's a big one. Motion theory. Buckle up.
Motion theory. Okay, so the premise here,
Mm-hmm.
from what I've been reading and from what you've been telling me off air, is that it basically says everything we think we know about reality, it's not quite right.
Yeah, that's putting it lightly, I'd say. This theory, this framework, it really shakes things up.
I mean, come on, time, energy, mass, the particles that make up, you and me, the forces that govern the universe, all different forms of the same thing. Motion seems like a
Yep.
stretch.
That's exactly what we're going to unpack today. We're going to dive into the source material you've got, try to figure out what this motion theory is really all about, and see if it actually holds water.
Yeah. Right, right. And, what really caught my eye, one of the first things I saw in this material was that it calls our traditional way of looking at things, it calls it a colossal fuck-up. Strong words.
Yeah, there's no mincing words here. The source is basically saying that these categories, the ones we use to understand the world, they've kind of become our blinders, that they're holding back scientific progress in some pretty major areas.
Quantum mechanics, gravity,
Yeah.
chemistry, even biology. They're all mentioned. So, where do we even start with this? It all boils down to motion,
Yeah.
right? But what do they actually mean by that?
Well, you have to understand, they're not talking about just, things moving around like cars on a highway. There's this crucial distinction they make between raw motion and structured motion.
Okay, raw versus structured. I'm intrigued. Lay on me.
So raw motion, that's the very base level. It's chaotic, random, without any real direction, like the static on a TV when you haven't tuned it to a channel yet.
Okay, I get that. Just pure undirected energy, essentially.
Right. But then you have structured motion. This is where things start getting really interesting. This is motion that's organized. It forms loops. It syncs up with other motion, and it stabilizes, becomes self-sustaining. And there are constraints, like the laws of physics and stuff.
And the source gives some pretty wild examples. They talk about hurricanes, how they form these incredible swirling patterns, but it all starts from random air currents, right?
Exactly. And then you have galaxies spiraling through space with their arms. And even at the microscopic level, things like a honeycomb, that perfect hexagonal structure. And what about electrons orbiting an atom's nucleus? Our own heartbeat, the rhythm of it.
It's like everywhere you look, there's this structured motion at play, bringing order to the chaos.
Exactly. And that's the really mind-blowing part of this theory. It's saying that the entire universe, with all its complexity and beauty, it emerges from this structured motion. It effectively beats out the raw, chaotic motion to create everything we see.
Wow. Okay, I'm starting to see how far-reaching this idea is.
Mhm.
But hold on. If everything is just motion, what about concepts like time, mass, energy, the things we usually think of as fundamental building blocks of the universe?
You're hitting on a key point. This is where motion theory really diverges from our traditional thinking. It reinterprets these fundamental concepts in a completely new way.
All right, give me the rundown. Let's start with time. We usually think of it as linear, right?
Right.
Past, present, future, like a clock ticking away.
Right, but in motion theory, time isn't some independent thing flowing along. They say it's actually the experience of structured motion-changing states.
Interesting. So, because things are happening, motion is unfolding, that's what creates our sense of time passing.
Exactly. And the past and the future. According to this, they only exist in our minds as memories, records of past motion, and as projections, our imagination trying to predict future motion patterns.
So there's no, real arrow of time, just the constant change of structured motion. That's wild. Okay, what about mass? We usually think of that as how much stuff something has, right?
Right, the amount of matter. But motion theory, it flips that idea on its head. It says mass isn't about the quantity of stuff. It's about resistance to change in motion.
Resistance to change. Explain that a little more.
Think about stable loops of structured motion. The more interconnected those loops are, the more they resist being broken apart or rearranged.
So the more organized the motion, the more massive it appears to us.
Exactly. That resistance is what we perceive as mass. That's why, this table feels solid. It's not that it's full of stuff, really. It's that the motion patterns at its core are incredibly stable. They resist change.
Okay, I'm starting to see how this all connects. So if mass is about resistant motion patterns, What's energy?
Energy, well, that's another one that gets redefined. In this model, energy isn't a thing in itself. It's not something that can be, stored or created. It's simply the transfer of structured motion.
Transfer of motion. So when we talk about using energy, we're actually talking about...
We're talking about the movement of these structured motion patterns, how they change and shift and get redistributed. A battery, for instance, it's not storing some mystical energy substance. It's a system that allows for a specific kind of motion transfer.
Fascinating. It really turns our everyday understanding of these concepts upside down, doesn't it?
Yeah.
Okay, I have to ask, what about particles? Like electrons, quarks, all those tiny things we learned about in science class.
Ah, yeah. Those. Forget what you learned about little, solid billiard balls bouncing around. Motion theory says those particles, they're not actually solid objects. They're more like dynamic zones where motion loops sync up.
Okay, I'm trying to picture that. So it's not that they're, both a wave and a particle at the same time, like that whole duality thing.
Nope. This theory simplifies it. Both wave-like and particle-like behaviors are just different ways those motion loops interact and are observed.
So even at the most fundamental level, it all comes back to motion. Okay, I got to ask about forces, like gravity. That's always felt like this mysterious thing acting at a distance.
Yeah, and that's another area where motion theory shakes things up. It doesn't see forces as mysterious pulls or pushes. It says there's simply the way that structured motion adapts and interacts across different scales.
Across different scales, meaning?
Meaning like the scale of an atom versus the scale of a planet. Take gravity. The way they describe it, it's this large-scale convergence of structured motion. Like, imagine a whirlpool in a river, drawing in everything around it.
So mass isn't attracting mass, it's the motion patterns that are converging.
That's the idea. And electromagnetism, they say that's all about the synchronization of structured motion patterns, how these rhythmic motions align and influence each other.
Wow. So everything from the biggest galaxy to the tiniest particle, it's all governed by the same principle of motion. It's pretty mind-blowing. But also makes you wonder, if this is so fundamental, why hasn't anyone figured this out before?
Yeah, it's a good question. And the source has a pretty compelling answer. They point to our human tendency to categorize things, to label them.
You mean like how we need to put everything in a neat little box?
Exactly. It was a huge advantage for our ancestors, being able to quickly distinguish between, say, a predator and prey. Essential for survival.
Right. Friend or foe, food or poison. But you're saying that this instinct has become a kind of a blind spot.
That's what they're suggesting, that this habit of categorizing, it's made us miss the underlying unity of everything, the fact that it's all motion at its core.
I see. So we're so focused on the differences that we miss the fundamental connection.
Right. And the source also mentions how technology, especially AI, it's actually giving us new tools to look beyond these limitations. It's like we're developing a new kind of vision, one that can see the unity behind all the apparent diversity.
That's pretty optimistic. So it's not like this theory is throwing out all of science, right?
Definitely not. It's more like it's proposing an upgrade, a more fundamental way to look at everything we already know.
Okay, I can get on board with that. So how does this structured motion, how does it actually play out across the universe? The source gives examples from our own bodies to galaxies and stuff, right?
Yeah, it shows how motion theory applies at all scales. Let's take your own body, your heartbeat. It's not just a pump, It's a complex system of rhythmic motion loops that synchronize the movement of molecules all through your body.
So it's like an intricate dance of motion happening at a scale we can't even see.
Exactly. And think about brain activity. All those neurons firing, it's all these incredibly intricate motion structures that are constantly forming and dissolving and reorganizing. Even something as simple as breathing, that's structured motion, molecules moving in a particular way.
So we are literally walking, talking embodiments of structured motion.
That's the idea. And if you zoom out to the Earth, it's rotation. It's not just spinning on its own. It plays a part in stabilizing the entire solar system's dance of motion.
Makes sense. Everything's interconnected. And the sun burning away up there, that's structured motion too.
Big time. They describe it as this incredible balance of atomic motion, the fusion happening inside. It's balanced against the pressure, all these forces in equilibrium. It's amazing.
Yeah, it is. So the solar system is all about these balanced loops of motion. And what about Entire galaxies.
Galaxies, those are even more mind-blowing. They're giant synchronization patterns.
Yeah.
Those spiral arms we see, they're not random. They're a result of motion optimizing itself across a vast galactic scale.
I'm trying to wrap my head around the scale of that. What about black holes? Those are still pretty mysterious, right?
Well, motion theory has an explanation for those, too. They're seen as motion synchronization sinks, like super dense zones where structured motion collapses in on itself and stabilizes.
So instead of a hole in space-time, it's more like a super concentrated knot of motion.
You got it. It's a
Yeah.
very different way of looking at it.
Yeah, for sure. So it really is a consistent picture, this idea that structured motion is behind everything. And the source also talks about certain shapes that keep popping up in nature, right? Hexagons, spirals, spheres.
Yeah, that's another fascinating aspect of this. Motion theory doesn't see these shapes as just coincidences. It says they're natural outcomes of structured motion operating under different constraints.
Like different rules or conditions.
Right. Take hexagons. They form when motion settles into a balanced state. Think about honeycombs, those perfect hexagonal cells, or snowflakes with their six-sided symmetry.
Right. And spirals, those show up everywhere too.
Spirals form where motion syncs up around gradients, where things are changing gradually, like a hurricane or the arms of a galaxy. And they're all about balancing those inward and outward forces.
And spheres, I guess those are the simplest shape.
In a way, yeah. They emerge when motion stabilizes evenly in all directions, like planets, stars, even soap bubbles. It's all about finding the most efficient, most balanced shape.
So it's not just that these shapes are, aesthetically pleasing. They're telling us something about how motion works at a fundamental level.
Exactly. It's like we're starting to decode the language of the universe, and it's written in these geometric patterns.
That's pretty profound. Okay, let's bring it back to, physics.
Yeah.
How does motion theory compare to our current understanding of the laws of the universe?
Well, it pretty much rewrites the book. The source lays out some very clear contrasts between motion theory and traditional physics.
Okay, give me the highlights.
All right, first up, gravity. Traditional physics sees it as a fundamental force. Motion theory sees it as the convergence of structured motion.
Right, we talked about that. What else?
Particles. In traditional physics, they're fundamental building blocks with inherent properties. In motion theory, they're dynamic loops of motion. No solidity, just motion.
Okay, energy.
Energy is not a separate entity in this theory. It's simply the transfer of structured motion from one state to another.
So no more conservation of energy law.
Not as we traditionally understand it. It's all about motion transformations.
And time.
Time is not a separate dimension flowing along. It's the experience of structured motion changing.
Okay, so that's a pretty radical rethinking of pretty much everything. What's the upside?
Well, the source argues that it makes physics a lot simpler. It gets rid of some of those weird paradoxes and infinities that plague our current models.
Makes sense. A simpler explanation is usually a better one.
Right. And it provides a more consistent picture of reality because everything is ultimately explained in terms of motion.
So it's a potentially more elegant and powerful way of looking at the universe.
That's the claim, yes.
Okay, so we've got this theory, this new way of looking at things. But is there any actual evidence to support it?
The source does point to some early experimental findings. For example, there's this thing called the quantum Zeno effect.
The Zeno effect rings a bell, but refresh my memory.
It's where constantly measuring a quantum system, it actually prevents it from changing. And they say this is evidence that quantum behavior is fundamentally about motion.
Because the measurement is interfering with the motion patterns.
That's how they interpret it, yeah. And then there's the fact that those hexagonal patterns we talked about, they pop up all over the place, from honeycombs to giant storm systems on other planets.
Right,
Yeah.
right. So that supports the idea that these shapes are a natural consequence of motion, right?
Exactly. And the source hints at some pretty exciting possibilities for future technology, like using motion synchronization to influence health and even longevity.
Whoa. Now that's something I'd like to see. So it sounds like it's still early days, but there are some promising signs.
Yeah, it's definitely in its early stages, but the potential is definitely there.
Okay, but let's be real. It's a pretty radical idea. Why would people even want to consider this? Why not stick with the physics we know?
Well, the source acknowledges that it's tough to abandon old ideas, especially when, our whole world is built on them.
Right, like our education systems, our technology, it's all based on a certain way of understanding things.
Exactly. And it's easier to just, dismiss this theory as philosophical speculation rather than actually grapple with it. But
Well, come on, don't leave me hanging.
but the source argues that the potential payoff is huge. If motion theory turns out to be correct, it could revolutionize everything.
Okay, color me intrigued. Give me some specifics. What kind of revolution are we talking about?
Well, imagine being able to control disease and aging. If we understand the motion patterns within our cells, we could potentially manipulate them to maintain health and extend lifespan.
That's a pretty big one. What else?
Think about controlling gravity and electromagnetism. If forces are just structured motion, we could, in theory, learn to manipulate them.
Like anti-gravity devices and free energy. That's sci-fi stuff.
It sounds like it, but that's the kind of potential we're talking about. And quantum computing. If we can master motion synchronization at the quantum level, we could create incredibly powerful computers.
So the possibilities are, like, almost limitless.
Yeah, pretty much. It's about moving from being passive observers of the universe to active participants.
Whoa. Okay, so big picture time. If you had to sum up motion theory, what would you say are the key takeaways?
Okay, first, it's a simple, and I mean really simple, interpretation of reality. Everything comes down to motion.
Motion is the fundamental building block.
Exactly. And it's not even really a new theory, more like a correction to our current understanding. Like taking off a pair of blurry glasses and seeing the world clearly for the first time.
And this clear vision, it could lead to some pretty amazing breakthroughs.
That's what the source argues, yes. It could be the ultimate lens for science, a way to explain everything in a unified and consistent way.
No more contradictions, no more mysteries.
Ideally, no. Everything is just structured motion, optimizing itself at all scales.
So I guess the big question for our listeners is, does this change the way you see the world? Does it make you question what you thought you knew about reality?
The source ends with a pretty powerful statement. Everything is motion. You are motion.
I think that's something we can all ponder.
Yeah. What does it mean to be made of motion? How does that change the way you see yourself, your place in the universe?
Those are great questions. And I think that's a perfect place to leave it for today.
Yeah, a lot to think about.
A lot to think about indeed. So thanks for joining us for another deep dive. We'll see you next time.
Until next time.